Good morning, students. We'll continue our topic of the chapter redox reactions. Yesterday we have done oxidation and reduction. Now we'll continue with oxidizing agents, reducing agents, and oxidation number. It means charge on the element and the balancing. So let's start. What do you mean by oxidizing and reducing agents? Students, a substance which undergo oxidation is known as a reducing agent, and a substance which undergo reduction is known as a good oxidizing agent. Always remember, an oxidizing agent is a chemical species that causes the other reactant in a redox reaction to be oxidized, and it is always reduced in the process. Whereas an reducing agent is a chemical species that causes the other reactant in a redox reaction to be reduced, and it is always oxidized in the process. It means whatever the species undergoing oxidation, it means loss of electron. It behave as a good reducing agent. And if the species undergoing reduction, it means gaining of electron. It means it is behaving as a oxidizing agent. Just see, an oxidizing agent itself reduce when it is oxidize something, and a reducing agent itself oxidize when it reduce something. For example, when magnesium reacts with O2, it forms MgO, magnesium oxide. So here, magnesium from 0, it changes its state to 2 positive, right? Because magnesium here is present in elementary form. So charge on magnesium is 0. And after addition of oxygen, it means oxidation has been taken place. So magnesium is oxidized and thus behave as a reducing agent. Or we can see here the oxygen has charge 0 and in product side it is -2. So 0 to -2 means they have oxygen has gained 2 electrons. So gain of oxygen is known as reduction. It means O2 is reduced and thus behave as oxidizing agent. So you can solve your problems by taking example of addition of hydrogen, removal of hydrogen. You can use any concept or electronic concept you can use, right? Here you can give answer which is being oxidized and which is being reduced on the basis of electronic concept of oxidation and reduction or classical concept. Both are correct. Suppose second example is when H2S reacts with chlorine, it forms sulfur and twice of HCl. Now here what happened? There is no oxygen atom there, right? But removal you can see. H2S is being oxidized to sulfur by chlorine, right? And chlorine is reduced to HCl by hydrogen sulfide, right student? So here Cl2 is oxidizing agent and H2S is reducing agent. Now, the next is oxidation number. Oxidation number means charge that present on atoms appears to given in a given species. No doubt we know about the charges of elements. For example, the charge of hydrogen is +1, the charge of sodium atom is +1, the charge of calcium is +2. But I'm talking about the charge when it is present with the other element, right? There are some rules to be followed to calculate the charge on the atom present in a molecule. So first is the oxidation number of an atom and its elementary state is 0. Students, elementary state means in which the element exists. It means hydrogen in nature exists in the form of H2. So it is having 0 charge, right? Sulfur 0, nitrogen 0, because sulfur exists in S8 form, phosphorus exists in P8 form, oxygen in O2 or O3 is 0 because they are its elementary form, right? Like zinc, copper, mercury, जो उनके एलिमेंट्स के सिंबल है वो उनकी एलिमेंट्री फॉर्म है, जिस फॉर्म में वो एग्जिस्ट करते हैं नेचर में, उन सभी के ऊपर चार्ज क्या है? 0 है, राइट? जब तक वो अकेले हैं तो वो 0 स्टेट में प्रेजेंट है, न्यूट्रल है. बट वो अगर किसी के साथ रिएक्शन कर रहे हैं और कोई कंपाउंड बना रहे हैं, देन दे हैव डिफरेंट चार्जेस ऑन देम. Second is fluorine has oxidation number -1. Fluorine, chlorine, bromine, iodine, all the non-metals, right, which belongs to fluorine family, they consist of -1 charge, as we know. Now, oxidation number of hydrogen normally will take the charge on oxygen is -2, but you have to learn the exception cases. For example, in peroxide state, for example H2O2 and Na2O2, its peroxide state में ऑक्सीजन का चार्ज -2 नहीं लेंगे, हम -1 लेंगे, और सुपर ऑक्साइड स्टेट में -12, and if it is present with oxygen, if OF2 is there, it means ऑक्सीजन डाइफ्लोराइड के केस में ऑक्सीजन के ऊपर चार्ज +2 होगा, और डाइऑक्सीजन डाइफ्लोराइड के केस में ऑक्सीजन के ऊपर चार्ज हमें +1 लेना है। तो हमें रिमेंबर करना है, याद करना है बेटे इस चीज को, कि हमने कब कौन सा चार्ज लेना है। नॉर्मली ऑक्सीजन कैरी, सपोज इट इज प्रेजेंट विद वाटर H2O, तो ऑक्सीजन के ऊपर हम -2 चार्ज लेंगे, राइट। बट अगर कुछ एक्सेप्शन केसेस हैं, अगर वो अपनी पेरोक्साइड फॉर्म में आ जाए, इट मींस H2O2 की फॉर्म में या Na2O2, तो हम उस टाइम पर उसका चार्ज -2 नहीं लेंगे, इंस्टेड विल टेक -1। The same as for oxygen difluoride and dioxygen difluoride. So you have to learn this. Again, the oxidation number of hydrogen generally will take as +1 in all the compounds, but minus when it is present with some metal. For example, lithium hydride. So in lithium hydride, lithium is already a cation. So hydrogen cannot be a cation. It is always anion. So here the charge in lithium hydride, जो चार्ज होगा हाइड्रोजन का, वो -1 होगा, right? So with non-metals will take the charge of hydrogen as +1, and with metal will take as -1. And the oxidation number of all the group 1 elements is +1, and all the group 2 elements is +2, as we know. And for complex ions, such as sulfate ions, carbonate ions, the algebraic sum of oxidation number of all the atom is equal to the net charge on the ion. Let's see the examples. See, first of all, how to determine the charge or oxidation state of any compound. Suppose you have to find out the charge of hydrogen in H2O. So, जिसका हमें चार्ज निकालना है उसको हम x सपोज करते हैं, सपोज द लेट द ऑक्सीडेशन स्टेट ऑफ हाइड्रोजन बी x, और जो उसके साथ स्पीशीज प्रेजेंट होती है उसका हम क्या करते हैं, उसके चार्ज को ऐड करते हैं। इट मींस सम ऑफ ऑल द ऑक्सीडेशन स्टेट्स ऑफ ऑल द एटम्स इज इक्वल टू ओवरऑल चार्ज ऑफ द मॉलिक्यूल, आयन और एटम। यहाँ वाटर जो है एक न्यूट्रल है, इसके ऊपर कोई पॉजिटिव चार्ज नहीं, कोई नेगेटिव चार्ज नहीं है, तो हम इक्वल टू में 0 लेंगे। हमने H का निकालना है H2O में, तो हमने X सपोज किया H को, तो it will become 2x plus -2, because generally we'll take the charge on oxygen atom is -2, which will equal to 0 and X equal to 1. It means in water hydrogen is present in +1 state. Similarly, if I want to find out a charge of nitrogen in this ammonium ions, right? Suppose or let the oxidation state of nitrogen be X. So we'll add all the charges. Hydrogen has charge of 1. Subscript के साथ multiply होगा. It will be 4. X plus 4 is equal to +1, because इस पूरे molecule के ऊपर charge +1 है. So X will be -3, right? Now, types of redox reaction. There are many types of redox reaction. We have done these types of reactions in our 10th class also, students. Just to recall, combination reaction. What do you mean by combination reaction? As we people know that combination reaction is that reaction in which compounds are formed as a result of chemical composition or chemical combination of two or more elements, right? So here's the example. बट यहाँ पे डिफरेंस क्या है बेटे, सिर्फ हमने चार्जेस भी मेंशन करने हैं। व्हेन यू विल राइट एन एग्जांपल ऑफ अ कॉम्बिनेशन रिएक्शन, यू हैव टू मेंशन द change undergoing, which species going oxidation, which is being reduced. So you have to show that also, right? So here are some examples given of these types of reaction. The second is a decomposition reaction, in which a single reactant decomposed to form two or more compounds, right? That is called decomposition reaction, and it is done in the presence of a heat, when heat is given, right? So here's an example of a decomposition reaction. And another is a displacement reaction. As you know, the definition of displacement, in which a more reactive element displaces the less reactive. So it is, the first example is of metal displacement, the second example is of non-metal displacement. And the last, which is very, very important and different in nature, that is a disproportionation reaction. And these are those reactions in which element in a particular oxidation state is simultaneously oxide and reduced. मतलब एक ही स्पीशी ऑक्सीडाइज भी हो रही है और एक ही स्पीशी रिड्यूस भी हो रही है. So you can see here chlorine having zero charge, ये -1 चार्ज में भी कन्वर्ट हो रही है और +1 में भी हो रही है. It means due to the formation of this ClO negative ions, chlorine act as a bleaching agent and it bleaches colored stain due to oxidation. तो यहाँ पर क्लोरीन जो है वो डिस्प्रोपोर्शनेशन रिएक्शन जा रहा है, एक ही स्पीशी दोनों काम कर रही है, ऑक्सीडाइज भी हो रही है और रिड्यूस भी हो रही है. इट मीन्स ऑक्सीडेशन नंबर इंक्रीज भी हो सकता है और ऑक्सीडेशन नंबर डिक्रीज भी हो सकता है. तो सच टाइप ऑफ रिएक्शन इज known as this proportionation reaction, which is very, very important topic, right? So the question can be asked, how do the following ions undergo disproportionation, like ClO negative, ClO2 negative, ClO3 negative? So examples are given in book, you can see. Last is balancing of redox reaction. So last portion of this video consists of a balancing. Student, balancing means to balance the number of atoms on both sides, right hand side as well as the left hand side. That is called the balancing of a redox reaction. But here balancing is something different. We'll use the concept of 10th class, but something different balancing is there. How? First of all, we'll write a skeleton equation. Now we have to assign the oxidation number to all the atoms. We have to identify the elements which is being oxidized and reduced. And you have to use the coefficient to equalize, to increase or decrease in oxidation number in reactant site. And then you have to balance all the atoms except hydrogen and oxygen. And then last step, finally, you will balance the hydrogen and oxygen atom by using hit and trial method. So let's see the example. The first example is C6H6 plus O2 gives you CO2 and water. So first step to find out, to write down the skeleton equation already written. The second, you have to find out the oxidation number. It means charge on each atom, right? You will not write here 4 charge on carbon atom because carbon is present with hydrogen. It has different charge. We know the charge of hydrogen. We'll write here +1 and you have to find out the charge of carbon by using X. X plus 6 equal to 0. So here the charge will come -1, right? 6x plus 6 equal to 0. So x will be -1 because you will multiply the atoms. एक कार्बन का चार्ज जो है, एक को हमने C को हमने x सपोज किया, तो यहाँ पे 6 कार्बन एटम है, तो it will be 6x plus 6 is equal to 0. You will find out the charges on all the elements and you have to identify which is going change in oxidation state. So here carbon from -1 to +4 and here oxygen from 0 to -2. You will find out the increase in oxidation number. Here from -1 to +4, the increase in oxidation number is, students, 5. But this is an increase of only 1 atom. But here we have 6 carbon atom. You will multiply 5 into 6, that will be 30. And oxygen from 0 to -2, there will be the decrease in oxidation number of 2. But here in, what you will do? Here you will multiply it with 2 because in what is there, only 1 oxygen atom is there present and here 2 oxygen atoms are present. So you will balance the charge. You will equate the increase and decrease in oxidation number on reactant side by taking out the common. So here common is 2 and 15. And after that you will balance the hydrogen and oxygen. I hope you have understood this. This is a second example. Just go through it. If you find any problem, you can ask me in your doubt class. Thank you so much.